Hello and welcome to EE233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at another pair of new functions that we've added to our core.h. The first one allows us the ability to add two parallel vectors, both of double data type, and under the assumption that they are the same length. And the idea here is we have two constant vectors, a vector O1 and a vector O2 that we're going to add element-wise, and then we're going to put the results of that addition then inside this vector underscore sum vector. Once we figure out how to do that, then we're going to repeat the process for our add double 2D array. So the only main difference between these two examples then, of course, is going to be the number of dimensions, because if you notice now, in our double 2D array, that in addition to keeping track of the number of rows, we've got to also keep track of the number of columns. So some of this is going to be about a little bit of bookkeeping. Some of this is also going to be about the idea of using parallel vectors. And what I mean by parallel vectors is essentially that these two vectors are going to be added element-wise. So in other words, the 0th element in vector O1 is going to be added to the 0th element of vector O2, and the result of that addition is then going to be placed in the vector underscore sum vector. All right, so without further ado, let's go ahead and get started. I'm going to go ahead and copy the two prototypes over to our core.c. We can go ahead and go all the way down to the bottom. And we can go ahead and paste these in. A little bit of cleanup, take the semicolons out, and add the curly braces. As before, we also want to go ahead and use the name and description comment header, which I'm going to leave to you to add. We want to at least have a small or short description of what each one of these functions do, so that later on in the future you can look back at your code and know what in the world you were trying to do. Once again, I'll leave that for you to do on your own time. Instead, what we want to do is we want to focus on the particular problem at hand. We're going to start with our add double vector. So both of these functions are relatively dangerous, if you would, from a perspective of accidentally overriding memory. They make the assumption that the calling function has done the correct memory management. In other words, it is allocated enough space, not only for vector O1 and vector O2, such that they're the same size, but also that your sum vector is large enough to be able to handle the results of the addition of those two vectors. Now, as earlier, we've discussed why we have an integer return value. Once again, we're simply going to return success or failure depending on maybe some basic logic inside the function, as opposed to returning a pointer or any other value. So in other words, the return value for most, if not all of these functions are going to be mainly for logic. So to begin with, we're going to declare a results variable. We are going to go ahead and initialize it in this case to exit underscore success. And then just to continue stubbing this in, we're going to return the results. Now, to speed this up a little bit, we can actually just copy and paste this down here to our second function. We're going to be doing a little bit different logic in that one. But in this particular example, really about the only thing that we can check is the value of n. Now, a little bit, I guess, of a philosophical discussion, or at least you could argue both ways, that the only time that we're going to have failure here is, of course, if our executable crashes for whatever reason, or at least for this function, is if n is a negative number. So technically, you could decide to add two vectors together that were of 0 length, and that wouldn't really be considered a failure. However, I would like to write the logic such that it requires there to at least be one value in the vector sum, just because it'll help you in writing your code in the future so that you don't have an additional thing to check. So what we could do here then is we could simply check to see if n is less than or equal to 0. And if it is, then what we want to do is we simply want to say results equal to exit underscore failure. Once again, in future use, you may decide that you want to do this a little bit differently for equal to 0 versus less than 0. But then under the else branch, what we're going to do is we're just going to assume then that all three of these vectors have the same capacity. In other words, they have the same, or at least the vector, the elements that we want to add together, there's enough of them in each one of the vectors. And the reason I say it the way I do is because technically speaking, vector 1 could be smaller than vector 2 as long as n match the size of the smallest vector. So that's an important distinction there. You can technically add two vectors together that are different sizes. However, you stop when you run out of elements in the other vectors. So in this case, we're going to assume that all three of these are essentially the same size. As before, we want to go ahead and create a index variable that will allow for us to build a for loop. So in this case, for index equals to 0, and index less than n, and index plus plus. And then from there, then it's actually pretty straightforward. We simply say vector underscore sum square brackets n underscore index is going to be equal to vector underscore o1 square brackets n index, and we add to it the value at vector underscore o2 square brackets n index. And so hopefully now you can see why we call these parallel arrays, because essentially what we're doing is we're matching up the elements in the array, or parallel vectors. We're matching up the elements in these vectors by utilizing the same index. All right, so unless, like I said, there's an issue with the count, we're going to be optimistic here. We're going to assume exit success. Technically, you could have initialized this to exit failure, and then once you've made it completely out of the for loop, then you could set exit success. So either is fine. Either approach is fine. I tend to be an optimist when programming. In this particular case, I'm assuming that the only time that we're going to run into an issue is if the results, or excuse me, n is less than or equal to 0. All right, so let's go ahead and give this one a shot. We're going to go ahead and build it, and we're actually it's going to take us longer to set this up than it will to have built the function, because we're actually going to then come back to our main here. And for this particular demo, we're going to have to set up two vectors to be able to test to see if this works. So we're going to be able to, we have to declare 3, but we actually have to initialize 2. So what we're going to do here is we're going to have an else if, and we're going to go ahead and use the name of the switch again, the function name rather, is the name of the switch. So we're going to check to see if argc is equal to 2, and we're going to go back to using string compare I for right now. And what we're going to do is we're going to compare argv square brackets 1, and we're going to compare it against the example or the function name that we just wrote, which if you want to come back over here and copy it, that's perfectly fine. So we'll just copy the function name and then add the slash in front of it. And if that's equal to 0, then what we want to do is we want to go ahead and set up two separate vectors. So we're going to go ahead and keep the same names here. They're both going to be the double data type. So we have a vector O1 and we have a vector O2. And now what we're going to do is we're going to initialize these things. And we've got two ways that we can go about doing this. we can initialize them using for loops, or what we can do is we can initialize and declare them all in one step. Now, for this example, we're going to go ahead and declare and initialize them all in one step just for a little bit of variety, although I will point out that I'm not a terribly big fan of this approach just because it has limitations as the vector or array becomes larger. So when we're doing the array example, we're actually going to use a nested for loop to be able to initialize these. But for this one, since these are going to be relatively small, we're going to just simply hard code this. So I'm going to start off, I'm going to create two vectors. Both of them are going to have 10 elements. The first one is going to start off at 0 and go up to 9. And the second one is going to go 9, start at 9, and then count down to 0. So we're going to start off 0.0, 1.0, 2.0, 3.0, 4.0, 5.0, separated by commas, 6.0, 7.0, 8.0, and then 9.0. And hopefully you can immediately see why this is not a very efficient way of going about doing this. So for the second vector, we're going to start off then with 9, 8, 7, 6, 5, 4, 3, 2, 1, and then 0. And hopefully just simply by lining these up like this, you can see the parallel nature of what we're trying to do. And also, more importantly, you can guess then if you sum these up, we're actually going to have the same values for all 10 locations. 0 plus 9 is 9, all the way through to the other end where 9 plus 0 is 9. So the only thing we need then is that third vector. So double vector sum. And remember that they do not have to be named the same as what we have in our function signatures. This is just to keep consistent. Now, I'm going to go and use our results variable. It's going to tell us whether we're successful or if we failed. And then what we want to do is we want to go ahead and add our double vector. And we want to pass to it first a vector underscore 01. We want to pass to it vector underscore 02. Our vector underscore sum, and then we also have to tell it how many elements to expect. So I'm going to go ahead and put 10 in here. We could, once again, utilize a temporary variable for n. For right now, we're going to just keep track of it ourselves. But now we have to figure out how to display it. In other words, to see if we've actually accomplished something. And to do that, I'm going to go ahead and we could create a temporary variable for an index, or we're going to just simply leverage our index variable from above. And what I'd like to do is I'd like to use printf now to print out a nice looking table here. So we're going to start off with vector underscore 01, vector underscore 02, and then vector underscore sum. And we'll play around with it. We'll see if we need to increase the number of spaces, etc. I'd like to throw in real quick a kind of a table border here. And once again, you can get as fancy as you want to. But then inside of here, I want to use a for loop. And this is going to be for index equal to 0, index less than 10. There's that hard coding that we want to try to avoid, but for right now it's okay. And then index plus plus. And the idea is we want to loop through these three parallel vectors and print out their results. So we're going to have a printf, and we're going to just stick to the %f for right now. And we'll see how much we have to work on our spacing. There's our 3%fs followed by a new line. For the first %f, it's going to be vector underscore 01 square brackets index. For the second one, you can imagine that it's just going to be vector underscore 02 square brackets index. And then the last one should come as no surprise, vector underscore sum. square brackets, index. Now, let's see if we've actually accomplished something. So I'm going to go ahead and copy this switch so that when we build this thing and we hopefully are successful. Nope, we seem to have a problem. That's good. Always like a few errors. Let's see what we've got here. All right, so we seem to have gotten quite a few. Let's see what we've got here. So did I mismatch? Let's see here, add vector double, vector 01, vector 02, vector sum, and then 10. So a little bit of a typo up here. I specified the values, but I forgot to specify the size. So we actually want these to be 10. And then there we go. It's again, easy thing to fix. Let's go ahead and build this. There we go. There's an amazing amount of errors just for a single mistake right there. Just make sure to include your array size whenever you are declaring your array. And now let's come back out here to the core demo and follow it up with the add double vector switch. And you'll see that we actually got this relatively close. We could afford to move this over by 2 characters each. So let's go ahead and do that. 2 and 2. Let's go ahead and build this one more time. And you'll see there are our 3 vectors. The first 2 are those constant vectors that we're passing to the function, and the third is the vector that is being updated inside the function. But fortunately, the values came out correct. So other than a minor typo, when we were declaring our variables, no big problems on this one. So let's jump in then to our next example. So which is going to be the add double to the array. And as you would imagine, this one's just got a little bit more error checking. And so the error checking means that not only must our n be greater than 0, our m must also be greater than 0. Okay, so essentially what we could do is we could technically have a n by 1 array, which would effectively look a lot like a vector to us, but there must be a value, a positive value for both n and m. And likewise, as we said in the earlier discussion, there is no way for us to guarantee that our arrays have been correctly allocated. We have to assume that that's going to be the responsibility of the calling function. So there's a lot of, I guess you could say we're taking a lot of this for granted in this particular example. However, though, we're going to essentially add an element in array underscore 01 to a element in array underscore 02. And then ultimately, we are going to put that value in the array sum. Also, if you've been following along with other examples, particularly the right multiplication function and some of our export functions, you'll notice that our arrays only specify a single dimension. Now, as you get more familiar with C, you'll know that there are several ways we can handle that. But for this particular example, what we're going to do is we're going to adjust our function signature to allow for that second dimension. And in this case, what we're going to do is we're going to add another set of square brackets in our function signature, and we're going to specify the size, or rather the maximum size, for that second dimension. And we're going to utilize one of our constants, m underscore max, that can be found in our core.h. And so for each one of our arrays, we want to simply add the second dimension. And then likewise, we want to go back to our core.h, and we want to do the same thing in our function prototype. As I mentioned, there's a couple of ways that we can go about doing this, but for this particular example, since we want to focus on the nature of the parallel vectors and the parallel arrays, we are going to simply append then the second dimension. So before we go any further, let's go ahead and build this just to make sure that we have no errors. And what we're going to do now is we're going to jump into our logic with respect to the n and the m. So n being the number of rows, m being the number of columns. So the first thing we want to do is we want to check, and we'll actually have three conditions to check here. We're wanting to check to see if our n is less than or equal to 0, because we said that was going to be a deal breaker, as well as we want to check to see if our m is less than or equal to 0. And then more importantly, then we want to check to see also if our m is greater than our m max, okay? Because we want to make sure that the m max, or the maximum number of columns that can be in our array, has not been violated. So remember that n and m are counts as opposed to indexes. So in this particular case, if m is equal to m max, that's perfectly fine. And so if any of those three conditions are met, then we have results equal to exit failure. And we could perhaps consider having better error codes for this particular function, since this starts to get a little more complicated. But essentially under the else branch then is where we want to do our operation. In order to do our operation, we have to have a couple of temporary variables, and one is going to be for the indexing in the number in the rows, and the other is going to be indexing in the columns, so n index and m index. And since we're going to be using for loops, we don't have to worry about initializing those. So as in earlier examples, we're going to start off with the rows first. So n index equal to 0, n index less than our n, and then n index plus plus. And then for the inner for loop, we simply use our m index equal to 0, m index less than m, and m index plus plus. And just a little bit of cleanup in our code to make it a little easier to read. And from there, then all we do is we simply say array underscore sum, square brackets, n index, square brackets, m index is going to be equal to array square brackets, array underscore 1, square brackets, n index, square brackets, m index, plus, and at this point we can perhaps be a little lazy because the only thing we're changing is 0, 1 to 0, 2. But hopefully at this point you get the nature then of the parallel arrays. In this particular case, we are adding two-dimensional arrays. And by the way, as a little side note, m can be less than m max. It's not required that is this m max. Matter of fact, it can be as little as one column for this to work. So let's go ahead and build this. Let's see if we've got any errors. And let's go back to our core driver and see if we can build a useful example. Now, once again, this is going to take us longer actually to build the example than it will to build the underlying function. So we're going to keep the example relatively small. And so we're going to go ahead and use the same logic that we've had before. So else if our argc was equal to 2, which meant that we were going to test the add double 2D array by checking using string compare I, our argv square brackets 1. And if that matched the add underscore double 2D array, then we know that what we want to do is we want to build up a example, or rather 2 example arrays, and pass them to our add double 2D array function. So to begin with, what we want to do is we want to go ahead and build these 2 arrays. And so we'll start off with double underscore array 1, and we're going to keep these fairly small, just so that we don't have a lot of trouble in distinguishing whether or not the values worked or not. So we're just going to make this, let's say, a 3 by 4, and we're going to do the same thing for our array O2. We're going to also make it a 3 by 4. And then for our array sum, and it also needs to be a 3 by 4. Now, as I mentioned earlier in the video, we manually created the vectors, and that's perfectly fine. There's actually a way to go about doing this with a array as well. However, though, it becomes a lot more cumbersome. And so what we're going to do here is we're going to use a nested for loop to generate these arrays. We're also in a later video going to use file inputs, which is more practical, or rather is more useful in a practical application. But to begin with, I want to go ahead and create 2 temporary variables. One is going to be an n index, and the other is going to be an m index. We're going to utilize them twice to build these arrays. So for n index equals to 0, n index less than, in this case, less than 3, because we've specified there's going to be 3 rows, n index plus plus. Likewise, for m index equals to 0, m index less than 4, m index plus plus. Now, we're actually going to utilize this a couple of times here. First, we're going to utilize it to build our array underscore O1, and we're going to use n index for the first index and m index for the second. And what we're going to do is we're going to come up with some sort of creative combination of the two. So in this case, what I'm going to do is I'm simply going to add the n index to the m index to initialize it. And then for array underscore O2, I'm going to simply multiply the 2. Once again, this is just a way of creating some information here, some useful initialization. All right, so basically we just don't want to have identical arrays. Now, what we want to do is we want to say results equal to, and then we want to add the 2 arrays together. So we have add double 2D array. We want to pass the first array, array underscore O1. We want to pass the second, array underscore O2. We want to also pass array sum, and then we want to specify that we're expecting 3 rows and 4 columns. And then provided that the results are equal to exit success, we simply want to print out these arrays. So the first thing we want to do is we want to compare results equal to exit success. And if that is the case, then we want to come up with a nice way of printing out the information. Now, there's a couple of different ways that we can go about doing this, but I'd like to see if we can't get a little fancier with this one. So we're going to go ahead and utilize our n index. So for n index equal to 0, n index less than 3. Once again, I'm hard coding this. You would probably consider using a temporary variable here for your n and your m. And then lastly, n index plus plus. This should be pretty much a standard recipe at this point. Likewise for our m index and m index less than 4, m index plus plus. And then what I'd like to do then is I'd like to add or demonstrate that we can add neighboring values. So in this case, what I'm going to do is I'm going to do a printf of %f plus %f equals %f. And I'm going to follow that up with a /t or tab. Now, in the first placeholder, I want to simply put array underscore 01 square brackets n index square brackets m index. So at this point, you probably see the pattern. You can probably go ahead and make a copy of those two indices so that you don't have to retype them over and over again. And then array underscore sum with the same indexes. So that fills our three placeholders. Now, the only thing to note, if you recall when we were exporting and also writing to our multiplication table, especially writing it out to the screen, is that you want to actually stop at one less column, 4 minus 1 or 3 columns, and then you want to follow that last column up with a new line. Okay, so basically we are duplicating our print outside of the inner for loop, with the difference being instead of a tab, we are printing with the new line. And so let's see how this looks. This may wind up being a little too wide for our screen. If it is, we'll play around with it a little more. We also seem to have some errors here. It stems from actually how we declared the arrays up here. I hard coded these values. Instead, we actually have to specify the m max as the number of columns because we indicated that was the size of the array in our function prototype. This will allow for us to get rid of one of our warnings. The other ones we're actually going to ignore for this example, and we'll come back to in a later example. And so if you go ahead and build this real quick, and you come back out to the command line here, and we will now change it to add underscore double 2D array. And you'll see here that essentially what I've done is I've created the two temporary arrays, the array underscore 01 and array underscore 02, which correspond to the first two values. And so we add 0 to 0, we get 0, 0 plus 0 equals to 0, and so on with the way that we have it initialized. And then for the second, actually, let's see here. I think we might have a little typo here. So let's see here, array underscore 01. Aha, so we failed to initialize the second array. There we go. Let's try that one more time. Seemed like we had a little too many zeros in there. All right, so we're going to go ahead and let's go ahead and rebuild this to get rid of the warnings. All right, and go ahead and run this one more time. Much better. So we have 0 plus 0 equals to 0, 1 plus 0 equals to 1, 2 plus 1, 2 plus 0 is 2, 3 plus 0, and so on. 1 plus 0 is 1, 2 plus 1 is 3, and so on. So now, hopefully you see how you can add two arrays together, in this case, two smaller arrays, even though we didn't use all of M max. So once again, you could have left these as 4 and ignored the warnings. We just wanted you to see how you could eliminate some of the warnings by changing this over to M max. So hopefully you found this video useful. If you've got any questions or comments, don't hesitate to email me. And as always, thank you for watching.